Welcome students. Today we will be discussing about applications of stack. So stacks are widely used in various applications including expression conversions, expression evaluation, syntax parsing, and other applications are also there. So this video would be dedicated to the first of the application, which is the expression conversion. So for that we will have to go through some definitions first, like what is an expression. An expression is a string of operands and operators. Generally represents an operation like an addition, etc. So say we have an expression like a plus b. So it basically represents an addition operation involving the two values or the operands a and b, and the operator in this case would be plus. So that leads us to the operators. Operators are the symbols denoting an operation. We have different kinds of operators in C, as you might have gone through all of them while studying C. So in case of a plus b, as we already discussed, plus is the symbol which tells the compiler that it is an addition operation. Similarly, the operands are some numeric values which are involved in an expression. These values can be variables or constants. Like in this case of a plus b, we are using the variables a and b. So we can easily have an expression involving constants as well. Like we can have an expression like 7 plus 8, which means that we are adding the two values 7 and 8, which are both constants but not variables. Similarly, what is an operation? Operation refers to a computation or action performed on data. Say in the current example that we are quoting, a plus b, a and b would be constituting the data of our operation, which in this case is the addition operation. Right? So that leads us to another topic, which is the expression types. What are the types of expressions? So in general, there are three types of expressions that we would be discussing: the infix expressions, postfix expressions, and prefix expressions. I have mistakenly written infix conversions, but it is infix expressions, then postfix expression, and lastly prefix expression. So what are the infix expressions? In this type of expression, the arrangement of operands and operators is as follows. That means your operator would be in between the two operands. So you have operand 1 on the left hand side, operand 2 on the right hand side, and in between there is an operator. Examples include, as we were just quoting, a plus b. So a and b, a is the operand 1, b is the operand 2, and plus is the operator. Same with other example. So for your kind information, this b minus c would be evaluated to some value. So that would constitute the second operand, and this in that case would be the operator, and this a would be the operand 1. Similarly, prefix expression means wherein the operator would be the first one appearing in the expression. Then you will have the operands, operand 1 and operand 2. Like you can see in the example, plus ab means plus. That means the operator is the first one to appear in the expression, and a and b would be following that operator. Similarly, in this example, you can see the operator first and then the operands. So what about the postfix expression? Obviously here, operator would follow the operands. That means you will have the operand 1, then operand 2, and then you will have the operator. So example would be ab plus. But remember here that it would again represent the operation of addition. That means we would be adding a and b. Simply the notation is different. Right? So a is the operand 1, b is the operand 2, and plus is the operator. So what about the infix to postfix conversion? Would be seeing an example. So example is a plus b. A plus b would be changed to ab plus. So here I think using the parenthesis is a bit of exaggeration, as you could have simply written a plus b. So we generally use these parentheses in case we have multiple operators and operands. So it simply means a plus b, and a plus b would be converted to ab plus in case of postfix expression. Let us take another example. We would be having multiple operators, like we have two operators here and we have three operands. So what is the mode of converting? So this is basically the theoretical way of converting. Obviously when you need to do it through computer, you will have a different algorithm, or you will have a definite set of steps that you would need to follow. So for the time being, we'll be doing things theoretically. So what is the procedure? Procedure here would be, since parenthesis give you the precedence of as to which operator or operation would take place. So here the innermost bracket or the parenthesis enclosing b minus c would be the first one to be evaluated, then followed by the rest of the expression components. So here a plus c would remain as it is, but this b minus c would be evaluating. Let us say we call it t1. That means term 1. So a plus would remain as it is, b minus c would be converted, or we'll call it as t1. But you will have to write on the right hand side for remembering thing that t1 is actually the term we have used for b minus c, but will generate a partial postfix expression of bc minus. So we'll not be writing b minus c but bc minus, just to remember things. So for the time being, we will go to another step. Now we'll be doing a plus t1. So a plus t1 we are calling it is equivalent to t2. That means we are writing t2 in place of a plus t1. So we'll be generating another partial postfix expression as t2 is equal to a t1 plus. So a is this a, t1 is this t1, and plus we have placed it on the right hand side of the two operands. So this t2 is equal to at1 plus. Now we would do a sort of back substitution to get the final postfix expression. So as I said, these are partial postfix expressions. So our final postfix expression would be generated by following the steps which I would be describing next. So start with t2. So what was t2 basically? t2 was at1. Write it again. Then a is a. What about t1? t1 is bc minus. So a bc minus came in place of t1, and this plus is representing this plus which was already there. So plus is plus. t1 was replaced by this bc minus, and a is a. So this would be your final postfix expression, right? So similarly, we have the infix to prefix conversion. So in case of a plus b, you will have plus ab. So this is as simple as the previous example. So let us take a slightly different example or the expression, which is a plus b minus c into d. So again you have the innermost parenthesis and you have other operands and operators as well. So here, any guesses? Yes, b minus c would be replaced first. But what would be the partial prefix expression? That would be t1 is equal to not bc minus but minus bc, right? So this would lead us to another step. So we'll write a is this a. So t2 has come in place of t1 into d. So what would be t1 into d? t1 into d would be into or asterisk t1 d. So basically t2 is equal to asterisk or into t1 d. Now finally we'll get a plus t2, we'll write t3, but we know t3 has come in place of plus at2, right? Because we'll have to bring this operator on the left hand side. So plus and then the two operands, which in this case were a and t2. So at2 plus, right? Now going for the back substitution. So we'll be starting with plus at2, right? Plus this or the t3 term. Then plus a would remain as they were, in this case plus a here, but instead of t2 you will be writing asterisk t1d. So asterisk t1d, right? So the final step would be plus a and asterisk would remain as they are. Instead of t1 I will be writing minus bc. So minus bc here, and d is this d. So at the end of this all, we will have no t's. So all the t's would be t1, t2, t3. They all would be replaced by the actual partial prefix expressions to get the final prefix expression, right? So $1 million question is, why would you convert expressions? That means infix to postfix or infix to prefix. So the answer is changing expression into postfix, which is also known as reverse Polish notation, or prefix, which is known as the Polish notation formats, simplifies the process of evaluating expression by eliminating the need of parentheses. So as you can see in the previous examples, that the final products you will have no parentheses, even though you started with the expressions having parentheses, but ultimately you will have expressions in case of Polish or reverse Polish notations that would have no parentheses with them. So eliminating the need for the use of parentheses and operator precedence. As I said previously also, that in, say, take this example here, it was the B minus C within parentheses. That means the parentheses suggested that, or made sure that, this B minus C was evaluated first. So in case of prefix and postfix expressions, since there are no parentheses, so it would be not necessary to remember the operator precedence. Another argument that would be put here is that since the operations in case of computers, you need only the operands and the operators, so what would be the role of the parentheses as far as computer is concerned? So your computer would only need to know the operands and the operators and put in a definite pattern or manner, so that it picks them up and carries out the concerned operation without having the need to remember any kind of operator precedence. So it would be better for computer to have expressions wherein there are only operators and operands. Right? That is why we change the expressions for the sake of computers to prefix or postfix expressions. We will be doing the algorithm for infix to postfix expression followed by the infix to prefix expression. Right? So let us say we have this expression A plus B minus C, and there are brackets also. So while doing the conversion, we will be taking up one token at a time, or one character at a time from the infix expression, and doing certain operations that we will be seeing shortly to the individual token. So if this bracket is encountered, what are we supposed to do, and what are we supposed to do with A, and so on. So you can have in the infix expression operands. So when operands are encountered, they are directly added to the postfix expression. Right? So while implementing this algorithm in C, that we'll be seeing shortly, this postfix expression would be stored in a array that would be called a postfix array, that would be titled as postfix. So the operands, when encountered, they would be directly added to that postfix array. Right? Similarly, for operators, what we will be doing is that they are pushed to the stack based upon their precedence. Higher precedence operators are popped before the lower precedence operators. Right? Then if we encounter an opening bracket, it is pushed onto the stack, while closing bracket causes the stack to pop until the matching opening bracket is found. Right? So for the time being, you will just be seeing the steps, but things should get hopefully clearer in the coming slides, as we'll be discussing the same steps with the help of an example. Right? So finally, once the infix expression is fully scanned, that means this. So we have taken up A, we have taken up plus, we have taken up this opening bracket, then B minus C, until we reached here. Right? So once the infix expression is fully scanned, the remaining operators in the stack are popped up to the postfix expression or the postfix array, as we would be discussing in the example in the next slide. Right? So these were the steps. So let us go to the example now. Say we have an expression of A plus B into C. We are converting this expression into postfix expression. Right? So to begin with, we'll need the services of two arrays, as I was just alluding to. So the first of the arrays would be the postfix array, and obviously we'll need the service of the stack array as well, because we are currently on the topic of applications of stack. So stack had to be there or playing a part in the conversion process. So the algorithm is that if you encounter an operand, it is to be pushed into the postfix expression as we saw in the previous slide. So here A has been read or scanned from the infix expression and we have appended it to the postfix array, right? Next, plus has come. Since it is an operator, it would go to stack. Then B is an operand, it would go to the postfix expression. Then asterisk, which represents multiplication and is an operator, it would go to the stack. And lastly, we have this C, and it would be going to the postfix expression. Now, since it is the end of the input or the infix array, we will be doing the pop operation of the stack till no element is there to be popped up. So in short, we will need to move this asterisk to this place or add it to the postfix expression, that this plus is popped up from the stack and it is added to the postfix expression as well. So our final postfix expression would be ABC asterisk into, which is what is being shown here as the output, ABC asterisk plus, right? Now we'll take a slightly more complex example which involves brackets also. So we'll be saying what comes as an input symbol from the infix expression and what are the contents of stack and the postfix array, right? So first we have taken up this opening bracket from the infix expression. It would be added to the stack or pushed onto the stack, and at this point of time postfix array would be short of any characters or contents, right? Then comes A would go to the postfix expression. Then comes the operator plus, it would go to stack, right? And postfix expression we will have A only, right? Then is the turn of opening bracket and it would again be pushed onto the stack. Then B would be pushed or inserted into the postfix expression array. Similarly, for minus, since it is an operator, it would be pushed onto the stack. Then C would go here, then opening bracket. Now interesting part is that we just discussed that when closing bracket is encountered, operators based upon their precedence are popped from the stack and put or inserted into the postfix expression. So since we have only one operator here, it would be pushed to the postfix expression till this opening bracket is encountered. So here, after popping up minus and inserting it in the postfix expression, we have encountered this opening bracket, which would be discarded simply but not put into the postfix expression. So the contents of the stack would now be only this opening bracket and plus. This minus was pushed here and this opening bracket was discarded, right? Since it is counterpart, that is this closing bracket, had arrived and it has caused this opening bracket to go away, right? So next item which is scanned from the infix array is this asterisk. Asterisk would be pushed to what? Stack. Then D would go here. And finally, we will have this closing bracket. Closing bracket would again make sure that the operators based upon their precedence are inserted in the postfix expression and the counterpart, that is this opening bracket, would be discarded. So there would be nothing left on the stack. If it was, then they would be, those elements would be directly pushed into the postfix expression. Since that is not the case here, we have exhausted both input array or the infix array and the stack contents as well. There is nothing on the stack. So the contents of the postfix array would be our final answer. That means ABC minus D asterisk and plus, right? So this is our answer. So this would be the postfix expression of this infix expression. Right now, coming on to the source code, we'll need the services of certain header files. Then we have for stack defined maximum capacity of 100 and top would keep track of the topmost element. Right, onto the main, we are basically asking the user for an infix expression, right? And then we are calling this infix to postfix expression method, which would be shown shortly, and it takes as argument this infix expression that we have scanned from the user. So for the time being, we can go to this function. So this is the function. So here we are doing the traversal part. While is used for the traversal, right up to from this place to this place, right? So in the while loop we are checking if the current input symbol is an operand, right, which is checked by this is a LNUM function. That means we are checking for alphanumeric character. If it is an alphanumeric character, what? Expression ith is the current input symbol from the infix expression. In this case, if we are starting the process, I would be 0. So it would be the 0th character from the infix expression. And we are checking whether it is an operand. In that case, it would be added to the postfix array, right? For which we have kept j as the iterator, right? So an operand when encountered, we have inserted that into the postfix expression. And if it is a opening bracket, then you push it onto the stack. If it is a closing bracket, then we are doing what? Until we reach the opening bracket, we are doing what? We are pushing that that x value which was popped up from the stack onto the postfix expression, right? So we are basically doing what? This would be the case when the current input symbol is the closing bracket. As discussed in the previous slide also, that will be doing the pop operation until we encounter the opening bracket. Until that, this x which was popped from the stack would be inserted in the postfix expression. Now the last else here is basically when we encountered an operator. So for operators, we are checking the priority. If priority of the stack top means what is at the topmost position of the stack. If its priority is greater or equal to the priority of the current input symbol from the infix expression, then we will do a pop operation. That means we will remove the item from the top of the stack and we will push it in the postfix expression. And since this is a while loop, this would go on till this condition comes out to be false, right? So what about this priority function? It is basically a function in which we are passing argument either stack top or the current input symbol. That means two different arguments, but the function name is the same. So for the time being, let's have a glimpse of that priority function. So here is the priority function. It returns you an integer value which is equivalent to the priority of the symbol which has been passed, in this case x. So if x is the opening bracket, then 0 would be returned. For plus and minus 1 would be returned. For asterisk and division operator, a slightly higher value of 2 would be returned, and for exponentiation operators, the highest value of 3 would be returned, right? So let us go back to where we were, right? So here priority of stack top is compared with priority of the current infix symbol, and if that is greater, if stack top priority is greater, then the pop operation takes place and the resultant character would go to the postfix expression. Finally, when this control comes out of this while loop, that means when this condition comes out to be false, then we will do a push operation in which the current input symbol would be pushed to what? Stack, right? Then I++ would simply increment the I and will go to the next input symbol or the infix symbol and repeat the process for that also till we have expired or we have exhausted the infix expression. So this code, this while loop is for popping remaining items to the postfix expression. Remember in the previous slide, we said finally when the infix expression or the array is exhausted or traversed fully, then as a last step, we pop up the remaining elements from the stack and put them directly in the postfix expression. That is what we are doing with this piece of code. So this is that priority function again, and we will need services of two more functions. One is the push function and another is the pop function, right? For the sake of simplicity, I have avoided that overflow and underflow conditions here. and the same here for the sake of simplicity, as I said. So I'm simply showing you that whatever comes in the form of x, I am basically pushing that onto the stack. Similarly, in case of this pop function, I am returning the stack top, right? So you lead the service of all these functions while converting the infix expression to the postfix expression. So if we just revise a bit, so we had started with main, we had taken up an infix expression, then we passed on to this infix to postfix. This is where we reached, and then we repeated this process as we discussed in just a few moments back, and will be needing services of this priority, this push, and this pop function while converting the expression. So finally, we will reach this point. So after returning from this method, infix to postfix method will be returning control to this instruction, which simply prints the postfix expression or the postfix array, which would be our final result, right? So now on to the infix to prefix conversion or the algorithm. First, this is slightly simpler, so you will find it also that the steps are that when we have an infix expression, we reverse the infix expression first. As a second step, we replace opening bracket with closing and closing bracket with opening brackets in that reversed infix expression. That means whenever you encounter opening bracket, you will replace it with the closing bracket in the infix expression or the reversed infix expression, and vice versa. So then you will obtain the postfix expression of the modified expression. And finally, you will be reversing the postfix array to get the prefix array or the prefix expression. So let us see an example. So suppose you have an example of a plus b into c. So first you will need to reverse the infix expression like this. So if we can see here, this is the opening bracket, this is the C, this is the asterisk, this is the B, this is the closing bracket, then plus and then A. So we have reversed and converted opening to closing and closing to opening brackets. Then we'll do the postfix expression conversion of this expression. So it will turn out to be CB asterisk A and plus. Then we will do the reversal of this postfix expression to get the final expression or the prefix expression, which is plus A asterisk BC. Right? Let us take another example, which is more complex than the first one. So A plus B minus C into D. Reverse the infix expression, right? So this is opening bracket, this is D, this is asterisk, and you will do the same while taking up other examples, right? So then we'll do the postfix conversion, and then finally we'll reverse the postfix expression to get the prefix equivalent prefix expression, right? Now onto the code, which is again simpler than the earlier conversion. So you will be taking up this infix expression from the user. You would be reversing that as a second step, but after reversing the infix expression, as we discussed in the previous slide, that you need to change the opening brackets and the closing brackets to their counterparts. That means if you encounter, while traversing this array, if you encounter this opening bracket, change it with or replace it with the closing bracket. Same for closing bracket, which is to be replaced by the opening bracket, right? So this process will go on till whole of the infix expression is exhausted or traversed, right? Then we'll call the infix to postfix function or the method which we saw in the previous slide. The same method I have called here, and after the control comes back after converting the infix to postfix expression, the reverse of postfix expression would be printed, which would be our prefix expression, right?